In this lesson, we will learn one of the applications of rational equations. These are typically referred to as work problems. First, I want to start by laying the foundation, talking about the logic of these types of problems. So consider example number 1 here. Jeff can mow 3 yards each day. Jason can mow 2 yards each day. How many yards can they mow each day if they work together? So Jeff mows 3 yards a day, Jason mows 2 yards a day. How many yards can they mow together? Well, here all you would do is simply add 3 plus 2 would be 5 yards a day if they work together. Okay, so pretty straightforward problem there. Let's compare that to example number 2. It takes Jeff 4 hours to mow a yard, and it takes Jason 6 hours to mow a yard. How many hours would it take them working together to mow a yard? So Jeff takes 4 hours, Jason takes 6 hours. How many hours would it take them together to mow a yard? So based on the first example, some people would be tempted to add these values together. 4 plus 6 is 10, but that doesn't make any sense. It shouldn't take longer to mow the yard if they work together. It should actually go faster whenever you work together. So here's the difference between example number 1 and example number 2. Example number 1 is written as a rate. 3 yards each day, 2 yards each day. It is perfectly acceptable to add rates together. But on number 2, we don't have a rate. It just says 4 hours and 6 hours. That's time. Add the time. Because it doesn't work that way, right? You wouldn't add it together because it should take less time when they work together, not more time. So what we want to do is we want to change this problem. Instead of thinking in time, we want to think as a rate. So think of it this way. Jeff takes 4 hours to mow a yard. That would be 1/4 of a yard per hour. 1 yard, 4 hours, 1/4 of a yard per hour. And it takes Jason 6 hours to mow a yard. So that would be 1 yard every 6 hours, 1/6 of a yard per hour. If we write it as a rate, we know from example number 1 that it is okay to add rates together. So I'm going to say here's Jeff 1/4 of a yard per hour. Here's Jason 1/6 of a yard per hour. And I want to know how long it takes them working together. So for them working together, they can do 1 yard in X hours. And all you would do is solve for X. So when you have a situation like this, you want to remember that you can only add rates together. If you have a time, you'll have to convert it to a rate to create an equation that you can use to solve, to figure out how long it would take them working together. Let's see a few examples from start to finish. One road crew can pave a section of highway in 15 hours, and a second crew working with newer equipment can do the same job in 10 hours. How long would it take to pave that same section of highway if both crews worked together? So here we have crew number 1, we have crew number 2, and we have what if they worked together. Now remember, they're giving us time, and we know it doesn't make sense to add 15 plus 10 because it shouldn't take longer when they work together. It should actually go faster when they work together. So what we're going to do is we're going to write this problem as a rate. So for crew number 1, they can pave 1 section of highway every 15 hours. That's 1/15 of a section per hour. Crew number 2 can pave 1 section of highway in 10 hours, so that's 1/10 of the highway per hour. And they're working together. I can add the rates, and what I end up wanting to know is 1 section in how many hours. And what we need to do is go through and solve for X. Now, you recall that whenever you're solving a rational equation, the first thing you need to do here is get a common denominator. So if I look at my denominators, I've got a 15, a 10, and an X. Well, I know that 15 and 10 both go into 30. So what I want is I want every single denominator to be 30 x. So I'm going to take this one fraction at a time. This first one I am going to multiply by 2x, which would make it 2x over 30x. The second one, I have a 10 on the bottom. So this one I'm going to multiply by 3x. That'll make it 3x over 30x. See how the denominators match? And we're going to do the same thing over here. This one has an x on the bottom, so all I need to do is multiply by 30. So this would be 30 over 30x. Now, once those denominators match all the way across, you just need to look at the top and use what's written here to solve for x. So what I see is 2x plus 3x equals 30. Well, combining like terms, 2x plus 3x is 5x equals 30. And I can solve for x if I just divide by 5 on each side. I get x equals 6. So what that tells me is that it takes 6 hours if these two crews work together. Logically, that makes sense, because if they work together, they should get the job done faster than either one of them could have done alone. Let's try another example. Working together, it takes Sam, Jenna, and Francisco, so this is all together, it takes 2 hours to paint one room. When Sam works alone, he can paint the room in 6 hours. When Jenna works alone, she can paint the room in 4 hours. And what we need to do is figure out how long it would take Francisco to paint the room. All right, so let me lay this out here. We've got 3 people. So I've got Sam, Jenna, Francisco, and then I also have what if they all work together. So I'm going to start filling this in. It says working together, it takes them 2 hours. So down here, they can do one room every 2 hours. That would be half a room per hour. All right, for Sam, Sam can paint one room in 6 hours. So that's one room every 6 hours. That's a sixth of a room per hour. Jenna can paint one room in 4 hours, so that's a fourth of a room per hour. And our question is about Francisco. We want to know how long it would take Francisco to paint one room on his own. So for Francisco, I'm going to write one room every X hours. That's what we're trying to figure out. Now, all together, because we're dealing with rates, tells us that we need to add Sam plus Jenna plus Francisco, and that should equal how quickly they can work on this together. All right, so we got 1/6 plus 1/4 plus 1 over x equals 1 over 2. And we know that in order to solve for x, we want to get a common denominator. So we got a 2, a 4, and a 6. Let's see. All of these go into 12. So what I need to have along the bottom, I need to have a common denominator of 12x. So I'm going to multiply each fraction by something that's going to get me to 12x. So for the first one, I could multiply by 2x. That would be 2x over 12x. The second one, in order to get to 12x, I'm going to multiply by 3x. So that'll be 3x over 12x. The third one, I just have an x, so I'm going to multiply by 12. So that'll be 12 over 12x. And the last one, I've got a 2, so here I'm going to multiply by 6x. So that'll be 6x over 12x. We've got that common denominator all the way across. Once we have that common denominator, we're really just looking at the top here and using that equation to solve for x. So what I see 2x plus 3x plus 12 equals 6x. I can combine these like terms. So I've got 5x plus 12 equals 6x. To get x by itself, I'm going to need to move all of my x's to the same side. So here I'm going to subtract 5x from both sides, which gives me 12 equals x. So what that tells me is it would take 12 hours for Francisco to paint the room all by himself? Let's try one more. Theo can paint a fence 3 times faster than his sister. Working together, they can paint the fence in 9 hours. How many hours would it take Theo's sister to paint the fence by herself? So here we've got Theo, we've got his sister, and then we have if they work together. All right, now filling stuff in, Theo can paint a fence 3 times faster than his sister. I don't know how long Theo can paint the fence, so I'm going to call him X. But I know that he's 3 times faster than his sister, which means that his sister takes 3 times as long as him. So if he's X, I would have to multiply his time by 3 to figure out what the sister is. So he's going to be X, sister's going to be 3X. So he can paint 1 room every X hours. Sister can paint 1 room every 3X hours, and together they can paint 1 room in 9 hours. So we're going to go through here and get a common denominator. Let's see, 3 goes into 9, so I want every single one of my denominators to have a 9x. So the first one has an x, I just need to multiply by 9. That makes it 9 over 9x. The second one, the bottom has a 3x, so all I need to do is multiply by 3. So this would be 3 over 9x. And the last one has a 9, so all I need to do here is multiply by x. So that would be x over 9x. Once you got that common denominator all the way across, all you really need to do is look at the top to figure out what x equals. So looking right across the top, I see 9 plus 3 equals x. So that's 12 equals x. Now remember who's who. Theo was x, so I know it takes Theo 12 hours to paint the room, and it takes his sister 3 times longer, right? It said that Theo can paint a fence 3 times faster than his sister. So if he's faster than his sister, that means his sister is going to take longer. So 12 times 3 would be 36 hours for Theo's sister.